Welcome to this module. Here like I discussed in last module, what we are looking at? We are looking at the loading effect, alright, and if I use a buffer between the inverting amplifier and a potential divider, whether it will remove the loading, alright. So, let us see first the screen and understand this is a part 4 of the same experiment, which is to study the effect of loading and input impedance. So, here if you see this first circuit is your potential divider, second one is your buffer, third one is your inverting amplifier, alright. So, we have voltage divider, we have buffer, or we can say voltage follower, we have inverting amplifier, right. We have these 3 circuit. Okay. So, if I connect the potential divider, this circuit to the buffer and the output of buffer to the inverting amplifier. This inverting amplifier has a gain of 10, you see 1 kilo divided by 100, this is gain of 10, alright. So, this has a gain of 10, which is my inverting amplifier. So, for understanding the importance of buffer, what we should do? Connect V out to the circuit shown in figure, V out is connected to your buffer, then apply 2 volts DC from power supply to V1. Here we are applying 2 volts DC, 2 volts, alright. Observe and note down the output V out 4 here. So, we apply 2 volts, we measure V out and we write down the expected V out, alright. So, for example, if I apply 2 volts, the output V out 1 here should be 1 volt, right, if the resistors are same. This voltage I am applying to the inverting amplifier has a gain of 10. So, my V out 4 will be minus 10 volts, right. So, this is my expected output minus 10. Now, let us see what is V out 4, alright. This is the experiment that we have to do. Again what he is saying, compare the observed output voltage V out 4 with expected theoretical value. This is the third thing that we will do. Finally, we will see what happens when we use the voltage follower, alright. So, let us do one by one. First we connect the potential divider and the buffer and the inverting amplifier. Here you see we have not used non inverting amplifier, here we have used the inverting amplifier. The advantage here, or not advantage, the ease of inverting amplifier compared to non inverting amplifier is that the selection of resistors. You see the gain formula for the non inverting amplifier would be 1 plus Rf by R1 or Rf by Rn. Inverting amplifier is minus Rf by Rn. So, when you understand that when you take the example of a non inverting amplifier, the resistor selection is very important. In case of inverting amplifier, it is little bit ease compared to the non inverting stage, and that is why we have considered here the inverting amplifier instead of non inverting amplifier, alright. Of course, there is one con, and that is the phase would be out of phase, the input signal and the output signal will be out of phase compared to the input signal, but then we have to use one more stage to again invert it to make it in phase with the input signal. So, let us see this circuit actually how it we can operate it. Again I will ask Suman to help us for this particular experiment as well. So, we are applying first voltage across the potential divider circuit, which is 2 volts. 2 volts is applied to the potential divider circuit, which is right over here, alright, it is right over here. Now, as we know the output is yellow color, this wire output of this potential divider is connected to the buffer. So, buffer, you see this is the buffer circuit, this is the buffer where my pen is. this is a buffer circuit, alright, and we have seen that how the buffer is that the inverting and the output is shorted and the non inverting is grounded in the op amp. This is your buffer. So, the output of this non inverting output of this potential divider is connected to the buffer. So, can you please connect it to the buffer? Okay. So, when you connect it to the buffer, right, and the output of this buffer is connected to the connected to the inverting amplifier. So, again potential divider, output connected to buffer, buffer output connected to the inverting amplifier. So, let us see now, if I apply 2 volts at the input, that is across the potential divider, what is my final output? Final output, that is output at the inverting output of the inverting amplifier. So, let us see, we have applied 2 volts, output of the inverting amplifier would be minus 10.10 volts. Let us write down what is output, minus 10.10 volts, alright. Let us apply 1 volt at the across potential divider, across here we are applying 1 volt. So, when we apply 1 volt, what is output? V out 4, that is the output of the inverting amplifier, minus 5.06, minus 5.06 volts. We are writing on the screen minus 5.06 volt. So, when we applied 1 volt across the potential divider, what we obtained? We obtained minus 5.06 volts, but when we applied 2 volts we obtained minus 10.10 volts by 10.10 volts. Now, what is the theoretical expected output V out for? Expected output would be minus 5 volts, alright, minus 5 volts how? So, if I apply 1 volt, the output V out 1 would be 0.5 volts, this V out 1 goes here, my gain is 10. So, 0.5 into 10, this will be 5 volts, right, and because it is an inverting amplifier, minus 5 volts. Very easy to calculate the expected output voltage. Here what you see now, here you see that the loading effect that we were talking about is not any more valid, because we have used the buffer. This is the importance of buffer, right. So, what is their fourth point? It will be seen that V out 4 again shows better compliance with expected output as compared to V out even with an inverting amplifier configuration. This is utility of using a buffer stage. Now, you understand what is the importance of using a buffer, that we have seen in earlier modules, right. We have seen voltage follower. The importance of voltage follower in this kind of application is to remove loading effect. One line answer, right. If you are asked in a question or in some interview that what is the role of buffer, right, or voltage follower, then you can give this example. Suppose I have a sensor which is a resistor sensor and I connect a resistor sensor to a potential divider, and if I connect potential divider to the inverting amplifier, you will see a loading effect. That to remove that loading effect, if I put a buffer in between, then I can remove the loading effect. That is the use of my buffer. So, then you are not only explaining how you are using the buffer, but you are also explaining where to use buffer with a given example of a sensor, right. So, this whole circuit when you talk, it looks a clear understanding and it gives a clear understanding, and we have in fact seen in the experiment that how the loading effect can be removed, right. So, if I quickly recall, this is a part 4. So, what we have seen? We have seen 4 different parts. First is we have seen just a voltage divider, right, and we have measured the output of the voltage divider. Then we have seen the inverting amplifier and the output of inverting amplifier. Then what we have seen? We have integrated the inverting amplifier with the voltage with the potential divider, and we have seen the effect of loading. Then we have connected the potential divider with the non inverting amplifier, and we saw that there was no loading. Then we have used potential divider, inverting amplifier, and we kept the buffer in between, and we again saw there is no loading, right. So, doing this exercise we understood the effect of loading and how we can reduce the loading, right. So, I hope that this particular experiment or set of experiments in several parts helped you out to understand what is loading and how we can reduce the loading effect by using a simple circuit or by using a simple op amp in an extremely simple configuration called voltage follower, right. You do not require any passive components to connect with the op amp to make it voltage follower. So, the importance of voltage follower, one example we have given, which is the reducing the loading effect, alright. So, in the following modules we will see more experiments, interesting experiments like this. Slowly and gradually as you go on understanding the modules, you will see the complexity of the circuit, I am increasing it. We will see differential amplifier, we will see instrumentation amplifier, and then we will finish this set of experiments and we will continue. So, I hope that once again that you understood the effect of loading. I will see you in the next module. By that time, take care. Bye.